Here we're going to continue learning about how to solve equations. These are going to be special types of equations that have variables on both sides of the equal sign. And it really is just one extra step where you need to combine the variables onto one side. You're going to follow similar steps where you always distribute and combine like terms first. So that really hasn't changed from solving a multi-step equation. You still distribute if you can, and then combine like terms next. This step 2 is the only real difference, and that's where we need to bring all of our variables to one side of the equation. And we always do that using inverse operations. And when I say that, I really specifically mean addition or subtraction. The next step is actually something that you should be familiar with. Really, it's just going to be a two-step equation at that point. We're going to move all of our constants to the other side. Still using inverse operations. And again, that's going to just be adding and subtracting. So by that point, we should actually just have a one-step equation, which almost always means we're just going to divide by the coefficient of the x. So I'm going to walk through these steps as I do the first problem. And when it says justify, that means I have to say the property that I'm using at each step. So if I can, I want to distribute. I don't see any parentheses. I actually can't distribute on this. Next, I want to combine like terms. I can combine some like terms. I know it's combining like terms because it's all happening on one side. It's 10x minus 6x, all on the right side of that equal sign. So my first step is CLT. I'm combining like terms. That becomes 4x plus 14 equals 6x. My next step is really step 2 from up here. I want to bring all of my variables to one side. I have a 6x on the left. I have a 4x on the right. I want to bring those to the same side. I already see that I have a constant on this side. I have this constant there. I want to leave my constant on the right side. I don't actually have a constant on the left. That really just means a number by itself, a number that's being added or subtracted that doesn't have an x next to it. So I see that I actually have that on the right side, which is telling me I want to move my variables to the other side. I want to move my variables to the left side. And that's what I'm going to do in my next step. I'm going to try to cancel out a 4x. You don't divide away the 4. That would only cancel out the 4. I want to cancel out the entire 4x. I'm going to subtract 4x from both sides. The reason I need to subtract is I need to cancel this out completely on that side. It completely goes away. That leaves me with 2x equals 14. I subtracted on both sides of the equal sign. I use the subtraction property of equality. And my last step, that's just my one-step equation. I'm going to divide on both sides. That's DPOE, division property of equality. My final answer is x equals 7. Kind of similar steps for the second one. I can't distribute. I actually can't combine like terms. Combining like terms means it's all happening on one side. That's not what's happening here. I actually can't combine like terms. That's only happening on one side of the equal sign. Right now I have stuff on the left side and stuff on the right side that I can combine, but nothing on the same side that I'm allowed to combine. So I need to follow step 2 from above, where I combine all my variables to one side. I have a choice here. I can bring the variables to the left side, or I can bring them to the right side. I'm going to choose to bring them to the left side. I want to cancel out this 1x. It's a positive 1x. To do that, I have to minus 1x from both sides. That's the only way to cancel out that entire term. The 1x needs to go away. I have to do minus 1x on both sides. That gives me 11x. I only combine it with this because those are the like terms. I don't touch that negative 13 yet. I can't combine that with the negative 13. That doesn't have an x attached to it. I just do 12x minus 1x, that gives me 11x. Minus 13 equals 9. I just rewrite the rest of the equation. Now I just have a two-step equation. I want to cancel out that minus 13. Really, now I'm bringing my constant to the other side. My numbers, by themselves, have to go to the other side. So I do plus 13 and plus 13. That cancels out the minus 13. That gives me 11x equals 22. And now I have one more step. I have to get rid of that 11 by dividing. So x equals 2. So my last step there in red was depot. My second to last step in blue was apo. I added on both sides. I added 13 and I added 13. Those properties only happen when you do something on both sides of the equal sign. I'm adding on both sides. That's called the addition property of equality. It's happening on both sides of the equal sign. That's why the word equality is. And then in green, in my first step, there and there, I subtracted 1x from both sides. That's S-P-O-E. Subtraction property of equality. All right, my next one, I see that I actually can distribute on this one. I'm going to distribute on both sides at the same time. So my first step is to distribute. And actually, I'm going to do this twice. I'm going to do it on the left side. 7 times 1, 7 times negative y. That's 7 minus 7y equals, I'm going to do it on the right side also, negative 3 times y is negative 3y. And negative 3 times a negative 2 is a positive 6. I write that as plus 6. I distribute everything I can. There's no like terms for me to combine on one side. I'm not allowed to combine these yet. They're on different sides of the equal sign. That is going to be my next step, but it's not called combining like terms. It's going to be either apo or spo. I'm subtracting or adding on both sides. You can go either way with this. You can bring the variables to the left side, or you can bring them to the right side. So I'm going to choose, just to cancel out this minus 7y, I'm going to add 7y to both sides. So I'm canceling out, subtracting 7y by adding 7y. That completely goes away. Leaves me with 7y, sorry, just 7. 7 equals negative 3y plus 7y is 4y plus 6. So I decided to add to both sides. That is addition property of equality. Now I have a two-step equation. I'm going to subtract the 6 from both sides. I want to cancel out the plus 6 by minusing 6 from both sides. Gives me 1 equals 4y. That is subtraction property of equality. And I have one more step where I have to cancel out the 4. That 4 is being multiplied times y, so to cancel that out, I have to divide by y. Sorry, I have to divide by the 4, excuse me. And I have to divide by that 4. That gives me y equals 1. My last step was division on both sides, that's dPOD. On number 4, my first step is going to be to distribute. I see that I can distribute on both sides. I'm going to do that. And I'm going to do it twice. I'm going to do it on both sides there. That gives me 9k. And 9 times negative 4 is negative 36. The 7k, that minus 7k, stays there. And now I distribute on the right side. Gives me 15k minus 10. 5 times 3 and 5 times negative 2. Now I'm going to combine like terms on the left side. That 9k and that negative 7k, or 9 minus 7, that becomes 2k. So far, I haven't really solved anything yet. All I've done is simplify the left side and simplify the right side separately. Now I'm going to come across and cancel out. It really doesn't matter which one. You can either subtract 2k or you can subtract 15k. It doesn't really matter which one. I'm going to subtract 15k. I'm going to do minus 15k and minus 15k. I really just need to cancel out one of the variables so that it moves over to the other side and combines with the variable on the right side or the left side. This goes away. That's the whole point of doing that. That's the whole point of subtraction property of equality. And that gives me negative 13k minus 36 equals negative 10. That's a really common mistake to drop that negative sign. It's minus 10 or negative 10. That's still a negative 10. You have to keep that sign with the number. Now I have a two-step equation. I'm going to add 36 to both sides. That gives me negative 13k. That went away, so I'm just left with the negative 13k. Equals a positive 26. I added on both sides. That is APO, addition property of equality. And my last step is depot. I'm going to divide by that negative 13. It cancels out on that side. That's the entire point, to get that k by itself. So k equals that number, which is negative 2. Oops. The whole point of this is to get the variable by itself. Before we can do that, we need to combine all the variable terms. First, we combine on just one side, and then we combine them between sides. We bring one across the equal sign to the other side. So I'm going to start by distributing that negative sign. It's basically like there's a negative 1 in front of this. That negative 1 gets distributed into both terms. Negative 5x minus 3x minus 4 equals 1 plus x minus 11. So my first step was to distribute. My second step is combining like terms. I'm going to do this twice. I'm going to combine like terms on the left side, because I see that I have a negative 5x and a negative 3x, or negative 5x minus 3x. That's negative 8x. And on the right side, I see that I have a 1 and a negative 11, or 1 minus 11. That's negative 10. So there I combine like terms. Combine like terms twice. All of my like terms are combined on the left side. All of them are combined on the right side. That means I need to start bringing stuff from one side to the other. It really doesn't matter which side you decide to go with. I'm going to decide to cancel out this negative 8x as my next step. Plus 8x and plus 8x. I'm trying to think about how to cancel out a negative 8x. You can't divide in this step. Not all of your x's are combined to one side yet. Combine all of them together. By canceling this out on the right side, that leaves me with negative 4 equals 9x minus 10. Now I have a two-step equation. I'm going to cancel out the minus 10, which is, sorry, let me go back to that other color. My last step there was APO. Now I can come to this bluish and add 10 to both sides. Trying to get that variable completely by itself. So I cancel out that minus 10 by adding 10. I'm going to add on both sides. That's called APO again. That gives me positive 6 equals 9x. And one last step, I'm going to divide by 9 on both sides. It gives me that x is either the decimal points repeating, or as a fraction, it's 2/3. Please notice that depot, the division, is almost always going to be your last step. You never really do it in the middle. This next one's a little bit unique because we have that fraction, and there's an x in that fraction. We cannot combine like terms yet. That negative 3x is being divided by 6, so until I deal with that divided by 6, I can't move that over. Actually, that's got to be my first step. MPRO, or multiplication on both sides, has to happen first. I have to cancel out the dividing by 6. This is stuck there. I cannot get rid of that. I can't get rid of the minus 3x until I deal with this dividing by 6. That cancels out, which is the entire point of multiplying. Gives me 2 minus 3x. The top is not affected. The right side, I'm actually going to multiply those two numbers together. 6 times 10 gives me 60x. My second step is going to be APRO. I know that because I want to combine my variables to the same side. I want to get rid of that minus 3x. I'm going to add 3x to both sides. That gives me 2 equals 63x. Then I have one more step. I want to get that x completely by itself, so I have to get rid of that 63. I'm going to divide by 63 on both sides. X equals 2 over 64. You can write that as a decimal, but you don't have to. Really, that division problem, that tells you your answer as fraction. And you might not be comfortable with me switching the sides there. This is the exact same thing as that. I can put my x on the right side or the left side. It actually doesn't matter. Either way, my last step was the division property of bar.